In this lecture, we will study curl of a vector field. Consider a vector field given by f equal to m of I plus n of j plus p of k. Here, m, n and p are functions of x, y and z. Then the curl of f given by this is defined as the determinant of I, j, k. Since the del operator is appearing first, we write dou by dou x, dou by dou y, dou by dou z, and then f, which is given by m, n, and p. Now we evaluate the determinant I. So dou p by dou y minus dou n by dou z minus j dou p by dou x minus dou m by z, and then finally we have the k component dou n by dou x minus dou m by dou y. If curl of f is equal to 0, then f is said to be an irrotational vector field. Notice that the curl of a vector field gives another vector. Now let us look at an example. Let the vector field be given by f equal to 2xyi plus x square plus z square plus yz k. We want to find curl of f. Curl of f equal to, let us write I, j, k. Then we will write the del operator, dou by dou x, dou by dou y, dou by dou z. Then comes the vector field f. 2xy, x square plus z square. Notice the coefficient of I goes in the I column. Coefficient of j goes in the j column. And the coefficient of k vector goes into the k column as shown. Now let's evaluate the determinant I. Then we get dou by dou y of yz minus dou by dou z of x square plus z square minus minus j is minus j. Give me dou by dou x yz and minus dou by dou z of xy. Then finally we have the k. K dou by dou x of x square plus z square minus dou by dou y xy. Now let's take the partial derivatives. This term gives me 2z minus derivative of this gives me z minus j. Derivative of this with respect to x gives me 0. Derivative of this with respect to z once again gives me 0. Then we have the final term k. Derivative of this with respect to x gives me x. Then derivative of this with respect to y gives me 2x. As you can see, this can be cancelled. This can be cancelled. So therefore we have I 0 minus j 0 plus k 0. So therefore the curl of f has given me 0. Thus we say f is an irrotational vector field.